we start, if you remember, from 2 slides of the last lecture. This slide is a kind of slide that will guide us as a generic, let's say, view of where we are in the course, and it's the stack of the so-called, let's say, SOAP web services. And there is one thing that is important, and that XML, it's common to all these various technologies or standards. So that's where we will start. We'll not start we'll give it for granted that there is some transport mechanism underneath. In our case, it will be HTTP for the most of the time, and which is, as you know, based on TCP/IP, but we are not going to go over it because you have already covered it in many times. Another slide that I also use to guide where we are in the course is the following, which is the problems that we need to solve for the web services, but in general for distributed system. And as I told you last time, these are solved with a number of standards. WSDL for the service invocation, SOAP for the data exchange, UDDI also, and some others also with the services, and with a stack of what's so-called web services star, which are protocols devoted to the quality control. The common thing, and that is where we start now, it's that they are based on XML, which is, as you know, extensible markup language. So we need to know this one from a conceptual point of view and from a practical point of view, because that's what we are, let's say, eating. We will be working and eating for the next, in this course in the laboratory. So this presentation, this introduction presentation is taken from Moller and Schwarzbach, and it's essentially the first part is just to know a little bit about the structure of this new language and what it is. So it is a language. It is a markup language. It contains all the information in the title already. It's an extensible markup language. So it's a markup language, and it's extensible, and that's the power of it, and that's actually the success story of it, in the sense that you can make up your own markup, your own tags. While in other markup languages, very common one, HTML, the tags are fixed by the grammar. Here in place, you can make your own tags, and so it's flexible, and as you will see, you can use it for many things, and in fact, it has been used for many things. In reality, when we say XML, is a very generic name. It is, you can think about it as a meta language. What does it mean, meta language? Is a language with which you can develop your specific language. Since it's flexible, you use it. And you just have to use the common syntax and the common rules of this framework of a markup language. And it's developed by W3C, so it's a standard and has been standardized in 1998. So we are talking about a technology, a language that it's something about, let's say, 15 years old now. So it's there for quite a while. And interesting enough, as I hope I will be able to tell you, it started as usual with one thing in mind, with one objective, and then has been used in many other different ways. That's very typical of web technologies. The web itself started with some idea in mind and then completely changed. So just to give you an example of what is the difference between what we standardly know and use as a markup language, which is HTML and XML, Moller and Schwarzbach are putting this kind of example. So let's take a typical HTML page. And this is a page which, if you read about it, and if you see how it is rendered by a browser, it is a page that's informed you about recipes in this case. And it's good. I mean, you can do it better. You can put, obviously, you can do it better from a presentation point of view. You can put CSS. You can use Bootstrap now or the new frameworks to make it nice. But essentially, what it is a series of tags. And it worked fine for presentation, but it has some limitation. It has some limitation for the things that we need to do. But in general, also, it has limitation for the web application in general. The big limitation is its initial purpose. The initial purpose of HTML was to describe hypertext, and so document, and not anything else. So in this case, it's recipes, but as we will see, you usually use it for something which is personal for you. The structure and the presentation is intertwined in the sense that you are essentially mixing up information about the structure, paragraph, headings, and things like that, with the way that you want to present it, bullet list, normal text, etc. And the validation is less. In what sense? That you can validate the file, and the file is validated as an HTML file that can be interpreted and viewed on the browser, but is not your specific application validation. So it's not a recipe validation. You can write, you can use it as a recipe, but that you can do mistake, you can forget the ingredients. You don't have you cannot enforce that some parts of that particular file, which is specific, should be there. The HTML validation is much less than there. Then there are some other things, minor but also important. Standards are shaky. Well, nowadays standards are, HTML standard is quite standards, but in the evolution there has been some browsers which have not been able to interpret all the HTML. Documents can be invalid, etc. So invalid in the sense that only some browsers can look at some particular HTML standards. So the idea is that HTML is fine, has been fine for a long time, but there's been a certain point in which you needed more specificity, more strength of the markup language, and in particular, if you want to do recipe, that's the things, you would like to have your own specific recipe markup language. And this is made possible by having an extensible markup language, which is the HTML. So going around in this example, what should we do? What is the things that we need for making our own markup language, recipe markup language? Well, first of all, the basic thing is that we need to be able to add our own tags, and that's what extensible is. And so we can use tags which has a meaning in our particular domain. This goes towards the idea of starting to put semantics in the language. Is not still a formal semantics, meaning that these tags are not formalized in some kind of vocabulary or ontology. But it's still, I mean, it makes sense to the people who are using for the moment, not to the machine. There are two steps in the semantics. One is the semantics for humans, and then we use our brain to interpret and see that that one is a recipe language. And then there is the semantic for the machine that it has an additional layer and takes a little bit more work. You can have data and metadata. You can have the data which are essentially the part which are inside the tags, and then you can have also information. In the tags you can have attributes that are carrying out information about the data. And there are many ways of doing it. Since everything is free, you have first of all to choose the granularity of the markup, how much you want to be precise, how is the structure, what you put in the elements, what you put in the attributes. So just to give you an example, the same kind of information that was given in the previous HTML file can be given, for instance, in something like this, which is now much more, I would see that we can agree, much more structured. It can have information telling exactly what we are talking about. So every recipe must have a description, an ID, a title, a date, a list of ingredients, a preparation, etc., etc., and I'm going. So it's the same kind of information, but put it in a more structured way and more defined. I'm now pointing here one extra thing that we will see in a few moments, and that is that with this kind of language, not only you are flexible in adding the tags, but eventually you can also be more robust in the validation. So you might want, you can apply to this particular file also some rules. These are external of the file. They are on another level. That, for instance, says that every recipe must have a title. Every recipe must have at least one ingredient, and etc., etc. So you can specify from some rules and make it more valid. But we will go back on this concept because it's very important for XML. So apart from the notation, usually in the markup language you need a number of things. The notation is the syntax that is essentially described, must be described somewhere. Where is described the HTML syntax in your, for instance? Do you know where it is described, the HTML syntax?
First line in which it's specified which version of HTML page is going to apply. So
yeah, that is true both for XML and also for HTML. The other thing is that most of the time, which is a correct answer, most of the time HTML is embedded somehow in the browser. So it's there where you have the browser are interpreting the syntax, which has a given version, which is the one which is on the first line, and somewhere there is the list. So the syntax is important, and it's important for one reason, both in HTML and in XML, and that is that if we have a syntax, we can view and also parse with automatic tools the language, because we can check that the language is formal. The other thing that is also useful is the way of showing this one in browsers, typically, because typically is the browser where we have the user interface. So we have style sheets. We have also the possibility of navigating through particular languages, XPath, which is essentially a query language. We can use it as a database, and in general, we have a number of web-based tools that that are essentially supporting this HTML notation, which are, for instance, the web pages, but also, as we will see, REST and SOAP web services. So let's start from the syntax, and then we'll go through all the other items slowly. The syntax of XML documents is very, very simple, and that is that all the documents are at the end mapped into a very, let's say, popular and efficient and well-known data structure, which is the one of a tree. So that is essentially the main properties that makes XML a well-formed markup language. A tree, as you know, has a root, can have child, parents, there is an order. Why it is a very good structure? Because it's one of the most efficient structure for searching. Because if you have your data structure organized as a tree, you can implement very fast searching and navigation algorithms. So that's an important thing. Another question. Is standard not the last version, not XHTML, but standard HTML? Is it a tree? The standard one? No idea? What is needed for a markup language to be mapped as a tree? There is a very simple syntactic rule. Every tag that you open must be closed. Okay, that's the minimum. Okay, then you have also to have a root, essentially this. And standard HTML, this is not true. You can have the typical HTML tags, which is not necessary to close, is paragraph. You have a paragraph, you put it there, and then you don't close it. Or you have new line, for instance, or you have formatting. Because it goes back to the fact that HTML is more towards formatting rather than describing some data. So one of the major things is this one to have a complete tree structure, meaning that it's every tag is open and then closed. Maybe in a very fast way, there are some shortcuts, but from the structural point of view, it's important. And when you have this one, then you can build, and that's the point of it, you can build very robust parsers that tells you if the syntax is okay and very fast. So you can be sure that when you open something, then you reclose it. A lot of analogy. Tree structure, you find it in many places in computer science, for instance, in file systems. And that's how it looks, the previous file of recipe. When you map it on a tree, you have a root node. We will go shortly back on that one. There is only one root node, not more than one. Then you have, if we saw it, if you go back and you see it on the slide, you have the collection. You can have a collection of a number of things. Every collection has a description. So these signs are for the nodes. The recipe, every recipe has some other components: title, date, ingredients, preparation, comment, nutrition related. The node can also have some parameters, some attributes. So you can add, these are information, these are the so-called data and metadata about this node. And at the end, these other things, you have the actual information. So all these things are tags. The rounded boxes are tags. And this final rombo here are the actual data, which are between the tags. And you carry it. And then, so data can be either within a tag or can be associated to the node as an attribute. Very quickly, there are a number of possible nodes. The things that are really more interesting for us are the text nodes, where we are actually carry the information. The element nodes that are only used for hierarchy, for the structure. Attribute nodes are the ones that are essentially attaching some information to the element nodes. And then you have the usual stuff that you have also in normal programming languages, because you need comments and sometimes you need processing instruction, which are always the headers, like where is the standard, to which format, what is the kind of the character sets that you are going to use. And then you have the root node, and in XML, every tree must have a root node, which, by the way, is implicit. So you don't even have to specify it. It is given automatically after you process the file. You know how it looks like, because I'm pretty sure that most of you have already worked with XML files. This is how it looks like without style sheets. It's just a text file. So it can be read by humans. That's the things about XML. It has two kind of end user, if you want to say. It can be used by humans. Humans would probably like it to have it a little bit better presented with some kind of style sheet, so that we can read it as a normal document without all these tags. And this goes to the point of the style sheet. But the nice things and the strength of XML is that it is done in such a correct way that it can also be read by machines. And that's the duality of its usage. And in our course, in web services and in services in general, we will use it in the second one. So what we need to know is the way of how to parse these documents and read it inside our program and process it. And we can do that because of this property of formness. I'm not going to go too much about the textual representation because it's the one that we saw before. There is a syntax that you can use, but that's so I will go very fast. The element nodes can be whatever you want, blah, blah, blah. They need to be open and closed, and there are these two main, let's say, syntax to do it. So explicitly or implicitly, or even a shorthand notation for empty elements. The attribute nodes, they have the possibility, you have to essentially specify a tuple, name plus value. Comment nodes have this particular syntax. Processing information, I have this other syntax with the question marks. And root nodes are implicit. But this is just syntax, so it's not very interesting. There are also some more constructs, more interesting ones. You can have, these are just the one that I said, processing instruction, comments, and declaration. So the syntax, I don't want to bother you too much with the syntax. You just look at it, and after a while you learn it because it's a common syntax. Maybe it's interesting to note that sometimes if you want to have some specific information that maybe have to be processed by other engine or typically JavaScript or some scripting languages that is there is the possibility to insert in your body messages of your nodes also generic data, like in this case a function. So here is just a wrap up of all the possible nodes. It's not a very interesting example of XML, but essentially what we have here is processing instructions. So are all the ones that are starting with the question marks and typically giving information about the versioning, and also if you have some libraries that you're using, it's where you want to put it. Then let's see, we have some attributes. This is a single attribute that is applied to the generic page. A declaration, which is on top, not that one. In this case, you are, as similarly to programming languages, you can declare something like libraries, for instance, or other pointers to other documents. In this case, this is a particular document, is a DTD, and it's something important that for validation. And we'll see later. And then you have, for instance, character data, comments, and everything like that. So, summarizing, the syntax is very simple, and everything that is essentially is that every XML file has to be mapped, can be mapped in a tree. And this means that start and end tags must match and must be nested properly. So you cannot close one before closing the previous tag. So it has to be really syntactically mappable exactly on a tree structure. So that's the main thing. And this is a very strong impact in the fact that the parsers are very simple, and there are a number of parsers out there that some of them we are going to use it, and they are very robust. Now, talking about application, and then we can finish this more or less with some extra this first part of the lecture. It all started in end of the 90s with the idea of building essentially a better and more flexible markup languages for web application. And so again, like HTML, the XML was essentially at the beginning a document-oriented language. So XML was for hypertext, and this was just, okay, let's do it right. Now that we've used it for many years, let's do it the right way in such a way that we can give support to different domains and a better support from the structural point of view. And this is happening, okay, has happened. And for instance, there is a version of HTML which is XHTML, which does exactly that. And there are also a number of specific document-oriented XML languages in various specific topics. I will show you maybe later some of these examples. Chemistry, but also theology or other things. So every domain that you want to define and to have a proper definition of a particular document, this is a good choice. Interesting enough, the simple idea of having a language which is a markup language which is extensible and well formed has been used even in some unpredicted ways. And the two ones that I'm mentioning here, or that actually they are mentioning here, are once you have a tree structure, the tree structure is a perfect structure for databases or for containing data. And so one of the direction of usage of XML has been on data-oriented languages. Essentially, you can build real databases, very efficient ones, and very flexible one because they are extensible, just using XML. And this is one direction. We are not really going to cover this one. We are going to cover this one. Another also unexpected, or let's say interesting application of XML has been in the definition of protocols. So one of the things that I told you in the last lecture has been that there has been through the years, and we are talking about really 40, 50 years, a big evolution of protocols and about communication, remote procedure calls, remote method invocation, and so forth. They were all very well, most of them designed, but they lacked the fact that they were not open. They were essentially proprietary, and it was not possible to exchange too much of the information about the internal definition. And so remote method invocation, for instance, you could use it only in a Java environment. The idea is to use this power of XML, of an extensible markup language, to describe in an open way so that everybody can read and everybody can share the particular protocols that you want to implement in your communication. So it's nothing about the structure of the document that you are exchanging, but it's about actually the protocol that you want. And this goes for the data, how you want to exchange data, for how you want to describe to the web your interfaces, like with WSDL, how you want to find the services, and how you want to combine together different services in order that you have a composed application that runs. So you can do a lot of things. So this really opens up a new way, and has been very successful, of describing protocols, or what is called also meta-programming languages. In particular, BPEL is a meta-programming languages. So you are combining together individual services in place of writing code, just by applying some particular tags. And obviously there are hybrids in which you do protocols and data-oriented, document and protocols, and things like that. But these are the three main ones. Yes, these are the example of specific application of document-oriented XML, like markup language for chemistry, where you can really see how it can be flexible enough to support the part which are interesting, the things that are interesting in chemistry. It can be used obviously also for the web directly with an extensible HTML, and there is no extension too much here of XML, but the fact is that it's only well-formed. This one is well-formed, while normally HTML could not be well-formed. And then, apart from this, you also extend it with your own tags. This is really the one that we will use the most. This part is not about the protocols, but it is about the documents. With this kind of language, what you can do is that you can define among businesses, an enterprise, or in the e-business scenario, you can define from the beginning how you want your documents that you are exchanging to be formatted. And so you can decide exactly the format of your document so that you can be sure somehow with some extra steps that when you send a business document or a public administration document or a health document in another area of application, can be understood on the other side. And also this, I always put it because I like it and they use it. It can be used in other domains like theology. This a particular XML theology markup language for annotating the Bible. When you have such flexibility, there is one common problem that you can have. Since I have the flexibility of using my markup language, you have the flexibility to invent your own markup language, and then maybe we can combine the two. And here is an example of a combination of an XML piece of file together with an HTML. So when this happens, I mean, the flexibility that we have can for sure create the possible construct use of the same tag in two or more languages. Okay, there is a kind of problem. Now we all know what is this problem since we are programmers, and that's typical in programming language where we can define our own variables, and then we are using libraries that are defining their own variables, and there is a clash between these two. So what is this I in the programming language? So this is a common problem, and there is a common solution, and the common solution is that one of a namespace. So for every language, you define a specific sublanguage, and you identify it in the web way, so giving it a uniform resource identifier that identifies it individually to this specific language. And then, so you can write your own markup language, give it a new URI so that everybody in the world can find it, the specification, and then you have just to specify in front of your specific tag what is the sub-language that you are using. XML, we will for sure see it in the actual usage of it. It's a very verbose language. Verbose meaning that it's very long, it's not very concise. It contains a lot of information, so you need it too. And this makes it even more verbose. If every tag that you want to specify, you need also to specify the sub-language, your files will become long and unreadable. But you know the solution because it's also the same one in programming languages, and that it is using the definition of a namespace. So you define at the beginning in the header of the file that you are going to use this particular HTML language, in this case is XHTML1, and you give it a funny name, okay, a prefix, and then you just need to use this prefix and not the long link. Or you can have a lexical scope in the sense that you can use a default namespace, and that's the typical thing that is done. So in every file you can specify at least one default. That means that all the tags for your file are going to be attacked to this particular sub-language. So you do it only one in the header, and then you don't need to do it. If you are mixing more than one language in one file, then one is the default, and then you have to specify with the other solution the remaining ones in order to make it work. So in the previous one, for instance, this was the solution. So the generic one was the www widget, and then the specific one was the extensible HTML. But you can decide, so this one has to be specified, all the other ones don't need to be specified. we can stop from this first part now, and this was just the introduction. These are some of the, obviously, many online resources that you can find on XML. You can find many. I will show you also an interesting website in which you can also do some small exercising on parsing and styling presentation of XML files. And I will stop now so we can have a 10 minutes break. And the second part of the lecture, just to give you the idea, is we'll go through the importance of these two elements of XML. The first one is the well-formedness, and we have essentially already talked about that. And we'll go to the next one, which is the validation and how it is done of the XML file. Okay, so we stop.